All right, in this video, we're going to talk about the real numbers and a couple of different operations as well, as you'll notice at the bottom of the screen. But again, this video is meant for Algebra 1 students, or really any algebra student who just wants to identify what types of numbers they're working with. So again, we have a few different classifications of numbers. One of the major ones that we work with would be the real numbers. The vast majority of what we do will be dealing with real numbers. Once you get up into the Algebra 2 level or higher, you may start dealing with non-real numbers. But for now, real numbers just basically refer to all the numbers that we deal with, negatives, positives, decimals, fractions, all of those things that we deal with. However, there are some smaller classifications of real numbers, and we're going to start at the bottom and work our way out. So again, whole numbers would be all the positive counting numbers. So whole numbers, which by the way, also I should say, and zero, all the positive counting numbers and zero, whole numbers would be 0, 1, 2, 3, 4, and so forth and so on. If we want a little bit larger grouping of numbers, we could talk about the integers. Basically, the integers are the whole numbers and the negative, if you would say whole numbers. So basically, notice how the whole numbers box is inside of the integers box on our screen here. The whole numbers, again, would be 0, 1, 2, 3, 4, and counting our way upwards. The integers would also contain 0, 1, 2, 3, 4, and counting our way up, but they would also contain numbers like -3 or -52, things like that. Any negative number as well, positive and negative counting numbers, of course, and 0. Don't forget 0 is also an integer, it's also a whole number. Technically 0 is still contained in those sets of numbers. The rational numbers gets a little bit trickier. The rational numbers, basically think ratio, means we can start talking about fractions. Any number that can be written as a fraction is a rational number. So things like 1/3 or 2/5, because we could write that as a fraction, even decimals, because 2/5 and 0.4 are the same thing, would be considered rational numbers. 1/3 is considered a rational number, so therefore so are any repeating decimals. Remember, 1/3, same thing as 0.3 repeating. So any decimal that either terminates, such as 0.4 or 0.257 and stopping, things like that, any terminating decimal or any repeating decimal, like 0.3 repeating, or it could be 0.43 repeating. Again, we don't necessarily know the fraction for that, but there is a way, I guarantee you, is a way to write that as a fraction. So therefore, anything that can be written as a fraction would be considered a rational number. There are numbers that are real, but can't be written as fractions. One good example would be things like the square root of 2. It has an infinite non-repeating decimal. Pi would be a really good example. It's a not rational, or what we call irrational. We'll learn about those later in the semester. It's not a rational number, but it's still a real number. So again, rational numbers, any number that can be written as a fraction can be considered a rational number. Now, things that we can do with rational numbers and or real numbers for that matter are find their absolute value. Remember that absolute value means the distance between any number and 0. So an often thought of definition or often thought of thing it turns all numbers positive. Any positive number stays positive, any negative number would turn to being a positive number, which also brings me back to those rational numbers. Remember, the integers are contained in the rational numbers. Remember, the rational numbers can also be negative. So again, rationals can be negative, real numbers can be negative, negative pi would be an example. We could definitely have negative numbers. The only numbers that can't be negative, again, would be those whole numbers in that box there. Talking of negative numbers, opposites, again, are two numbers that are the same distance from 0. So one number being positive, one number being negative, such as our example at the bottom there, 7 and -7. Those would be opposites. Again, they're the equidistant from 0, but one of them is positive, one of them is negative. So in that case, let's just talk about a few examples of things that we can do. We'll just kind of walk through here. Again, talking about opposites, the opposite of the number 7 would be the number -7. The opposite of the number -4.5 would be +4.5. Again, one of the numbers being positive, one of the numbers being negative. On the other hand, when you talk about absolute values, the distance from 0, -4.5 is exactly 4.5. units from 0 on a number line. And 7 is also 7 units from 0 on the number line. Again, you don't need to make those negative. They're going to stay positive. Absolute values are always, or answers to absolute values are always positive numbers. If you want to, think about the numbers down here at the bottom. Try to classify them. What would be the most classified number, or technically just which boxes would they qualify as? I would recommend doing this in your homework as well. When you're asked to identify a number or classify it, put it in a chart like this and see what's the most narrowed down, what's the smallest set of numbers that it would classify as. If you want to try ahead of time, pause the video now. I'm going to fill in the boxes here in just a second. All right, when we're talking about negative 4 makes me think, well, that's not a fraction, but technically negative 4 over 1, right? We could put that over 1, would be a fraction. So therefore, negative 4 is definitely real. It's definitely a rational number. Remember that integers can be negative, so I would say it's definitely an integer, but whole numbers can't be. I'd say that's a negative counting number. The most classified or the most narrowed down that it could be is an integer. Pi, remember, is approximately 3.14 ... Therefore, it's not a whole number. It's not an integer. Remember, neither of those can be decimals. But I would say that it's also not rational. Pi can't be written as a fraction, or at least a ratio of, integers or whole numbers. So I would say pi is just real. It's not even a rational number. 17, on the other hand, is definitely real. It's definitely rational. It's an integer. And I would say it's a whole number. It's a positive counting number that's not a fraction. And then finally, again, whole numbers can't be fractions. Integers can't be fractions, but rational numbers can. So again, a ratio of integers, -3 and 5. That's definitely a rational number, and all rational numbers are real numbers. I hope that helps you classifying numbers and also doing a couple of operations with them. If you have any questions, make sure you talk to your teacher. Have a great day.